one highlight for me of the National Centre for Energy Systems Integration would be the collaboration that led to an additional demonstrator, which is Integral. So that's the Integrated Gas Electricity Transport Laboratory that is developed in partnership with Northern Gas Networks and Northern Power Grid. Newcastle University were quite heavily involved in the development of that, and it became a demonstrator for CESI that we're now actively continuing to develop with Northern Gas Networks and to develop new project ideas as they build out the new customer energy village on site. Another highlight for me is at the very beginning of CESI we set up these task and finish groups, one of which was on blockchain, and that was done in collaboration with some of our industry partners as well as the academics. And the work that came out of that, which Melinda at Heriot-Watt led on, that has been really heavily cited and has actually been cited in government policy documents in the US. So that's a really lovely highlight to show that something that we developed as an idea just to get us collaborating led to some really impactful work. So a third highlight for me is the career progression that we've seen in the team that have been working on the National Centre for Energy Systems Integration. So we've had a number of academics be promoted to Professor, congratulations to them. That includes myself, Chris Dent, David Flynn, Valentin Robu. And then we've also had some of our researchers move on to new projects or out into industry. So Hamid Hosseini and Mohammed Royapour at Newcastle, for example, have both gone out into industry. And also our project manager, Laura Brown, left us to step into industry as well in a new role. And we still keep in touch with all of those people and have some really nice working relationships with them now that they've progressed in their career in industry.
Gordon Mackerron here from Work Package 1. A few highlights of what we've done in the commercial, regulatory and policy aspects of energy systems integration. First of all, there is potentially a tension between the fact that there is decentralization in energy technologies, evidenced for example in small-scale renewables, and the notion that if we do energy system integration we may need a greater degree of centralization, for example if we combine electricity control rooms with gas network control rooms. And indeed the first highlight I'd like to mention is a very interesting project which involved a collaboration between people like Simone Abram from Durham Anthropology and other people from Newcastle University who are involved in engineering and modelling. And it looked at some of the issues that arise if we try to integrate control rooms into the future, both in terms of working practice as observed anthropologically, and some of the system issues that arise when it comes to the technical questions of how you actually manage gas and electricity networks jointly. And that was, I think, a fascinating and very interesting project. Second highlight I'd like to mention is that we were very concerned to look as creatively as possible at energy futures, how energy systems might look up to the year 2050, not being so constrained by some pre-existing quantitative models that tend to assume that past relationships are simply extended in a larger sense into the future, but by democratizing it a bit, by looking at stakeholder visions, and not being so constrained by the sorts of mathematical modeling that are often used that tends to actually constrain the level of imagination for futures. And we found, both in looking at the Findhorn community in the north of Scotland and the north of Tyne in the northeast of England, that there were common elements that are not always reflected in traditional quantitative methods, particularly a growing concern with issues of fairness as well as decarbonisation and questions of cost. The third highlight I'd like to mention is a project led by Karen Turner from the University of Strathclyde that looked at what might be happening as electric vehicles are likely to spread, to the ways in which electricity networks will have to expand, and in particular a political economy analysis, in other words, who benefits, who loses from the extension and the cost of the extension of the grid to take care of electric vehicles, bearing in mind that poorer people are likely to have less access to the benefits, and that's use of the electric vehicles, but more likely potentially to pay for some of the costs in their own electricity bills of extending the network. So I hope that gives you some broad impression of the kinds of things we tried to do in Work Package 1, and hopefully you'll be interested to find out more by looking at the work we did. And thank you very much for your attention. Bye-bye.
So for me, one of the strongest features of CESI has been timing. The energy transition that we're going through at the moment has a scale and a pace beyond anything that I've ever seen in my lifetime before. So it's been fantastic to have the project running over the last 5 years. It's given us a platform through which we've been able to contribute to the new thinking that's needed to deliver that transition. So the timing really couldn't have been any better. A second strong feature of CESI for me has been the outreach activities that we've done. We're a consortium of 5 university partners, and we've had strong industry engagement from the start, with Siemens as the major industrial sponsor of the programme. So that's enabled us to have good outreach into the academic community, both nationally and internationally, and also into industry throughout the project. But beyond that, we've also been able to engage strongly with local and regional government, local organisations such as the North East Chamber of Commerce. On the national scale, we've been engaging with the parliamentary group on energy studies. In terms of the science and engineering community as well, doing events with the British Science Festival, for example, has also been a big feature of our outreach activities. So the outreach of the programme has been very strong and something that we can be proud of. And then the third feature that the third highlight of CESI has been location. So much of our energy transition is happening in the north. In this region, if you look at the inward investment, for example, we've got British Volt building the battery gigafactory up at Blyth, Siemens Gamesa investing in the wind turbine manufacturing and assembly plant in Hull. We've got the cables coming ashore of the world's first gigawatt scale offshore wind farm in East Yorkshire, the first phase of Hornsea 3. And that's soon to be followed by Equinor's investment in the Dogger Bank offshore wind farm, with the cable coming ashore here in the northeast of England. There's lots of new collaborations that have started as a result of CESI, and it's been fantastic to have that based here in the north of England, where so much of the energy transition is occurring.
Hi, my name is David Flynn. I was one of the Associate Directors of CESI and the Work Package 4 Energy Demand Lead. So areas of particular note, I would say very proud of the impact and continuity in our people and place centred research. So starting originally engaging with communities in Findhorn, expanding to include communities in the north of Tyne and the southeast of England, and then most latterly being part of the team that co-created the UK's largest whole system multi-vector energy project called Reflex, which was based in Orkney. So in terms of the research, we got to grips with the knowledge gaps in social techno-economic modelling and optimisation, tackling the issues of wealth distribution in communities from community-owned assets. Beyond the academic learning and the knowledge transfer to industry, what I was really impressed by was the continuity of engagement in over 5 years, the transferability of the learning across the communities, and how it led to specific solutions for the specific needs of those communities. A second area of great pride is seeing the early career researcher development and the wonderful diversity embodied within that. Due to the visibility of CESI, the scale of the partnership across communities, industry, academia, a global platform was more readily accessible to these researchers at an earlier stage of their career. And having that rich environment, that diversity of conversation and engagement, we've seen output papers on the likes of smart contracts, blockchain technologies, which have had a direct influence on UK and international government policy. So that was brilliant to see. In terms of a third point of notable impact, and I select this one because it's so relevant to the energy transition in front of us and for the foreseeable, is our research looking at both the kind of top-down energy system modelling and the ground-up people-in-place transition I was mentioning, was that we identified a lot of the considerations we must have given the use of big data, cyber-physical technologies in the energy transition. So CESI outputs have identified some of the opportunities, the risks, the mitigations, the pathways we want to fully evaluate. But given the complexity of that field of research, it's going to remain an area of central focus for energy community stakeholders for the foreseeable, and really proud of the fact that we identified some of those foundational challenges and opportunities in that space.
So my name is Patsios. I'm a senior lecturer in power systems, and I'm leading the work package on demonstrators for CESI. So by demonstrators we mean either assets or sites or infrastructure, anything where we can demonstrate capability, like this nice building here, the Urban Sciences building. So basically what we do in these work packages is either use these kinds of sites, assets or experiments to validate models that we've got, or to help us build these models by, for example, informing them with data. We've achieved that on a number of occasions, for example, publications where we've actually validated the response of physical assets using our lab facilities, or even where we've used the demonstrators to generate data, or even new projects like the building as a power plant project, where we actually tested the performance of this building to provide demand-side response. In other occasions, we've even expanded this capability, the original demonstrators that were in the scope of the original CESI proposal, with new sites like, for example, the Port of Tyne, where we've established and created or co-created projects with our industrial partners, for example Siemens, where we looked into decarbonization of major sites or local energy systems like the Port of Tyne.
Hello, I'm Phil Taylor, the Pro Vice Chancellor for Research and Enterprise at the University of Bristol, and I'm also the leader for Work Package 6 on CESI, the Centre for Energy Systems Integration. Work Package 6 looks at multi-scale architectures, planning and operation. And CESI seeks to gain a deeper understanding of how to achieve a just transition to net zero, and I think we've certainly done that in the recent years. And what we try to do when we're considering the benefits and risks and thinking about a just transition to net zero, we take care to consider how those benefits and risks are distributed across society, industry and governments when they occur. We think that's a really important distinction from a lot of other research in this space. So the research programme was built on a number of underpinning principles. First of all, that we felt a whole systems approach was needed to do this work justice. Now that doesn't mean you have to model or understand the entire energy system in everything that you do, but you must at least consider the entire energy system and beyond in some cases, and the interfaces between the work you're doing and some of those other parts of the whole system. We think this necessitates interdisciplinarity, which then in turn necessitates highly collaborative approaches, and we've sought to behave in that interdisciplinary collaborative manner, working with academia, industry, governments, communities and society in general. We also felt, and this was a key principle for CESI right at the outset, was that there was a need to adopt bottom-up approaches to experimentation and analysis. We felt there was a predominance of top-down energy systems work, and that meant there was a lack of spatial and temporal detail in energy system integration research practices. And then where that leads you is that if you're taking bottom-up approaches, then really you need to build full-scale multi-vector demonstrators. You need to develop those with partners so that you can collect data, you can validate models, and you can run calibration exercises and try and understand the real-world challenges of energy systems integration. So if I think now a little bit about the highlights for me personally, one of the really challenging things we set ourselves at the outset with CESI was to develop something we referred to as a co-evolution methodology. The idea of this co-evolution methodology was that it wasn't a linear process and it wasn't just a techno-economic process. It was an iterative process that involved social sciences, expert users, end users, policymakers in understanding what the needs, the fears, the aspirations of different organizations and stakeholders were for the future of energy systems as we saw those just pathways to net zero. And we did this at 3 levels in CESI. We did it at a small regional level for an eco-village called Flynn in Scotland. We then moved up to a regional level and did this at the North of Tyne Combined Authority level. And now we're getting towards the final stages of running this approach again, but at a national level. And we've had many insights we've been able to share with policymakers, with industry, with local authorities from this really quite radical co-evolution approach. I found that really inspirational and learnt an awful lot. And in the process of doing that, we've developed a lot of different models with competing approaches. And we've also developed an integrated modelling environment where we can bring all those models together and connect them and see how they interact. Another thing I thought was wonderful was when we worked with Siemens to link demonstrators with energy systems models in real time through the use of digital twins. And we were able to do some really exciting work there around the impacts of the enhanced frequency response market that was launched by National Grid. And we were able to get insights for industry there before that market was even launched. We also managed to influence Ofgem. We talked to them a lot about the benefits of greater energy systems integration and the need for gas distribution and electricity distribution companies to consider the other vector in their ED2 and GD2 submissions. And we saw Ofgem actually stipulate the need for that in those requests. And then finally, another wonderful thing we did was through the Flex Fund process, we were able to fund a very diverse community in energy systems integration, bring those people into this space, grow the energy systems community. We were able to fund work on EV policy, asking who pays for infrastructure upgrades and is that fair? So all in all, it's been a fantastic experience, which I've loved, and I think we have managed to deliver some real value. Thank you very much.